The next operation is centering, as you see in this drawing. In the configuration of our machine, this is the tool to make centering is in configuration of our machine, a tool from B-axis. Let's check position of this centering tool in the tool catalog. This is the tool on lowest position, T302. We should discuss B-axis at the beginning. The range of movement is shown in this drawing, as you can see, and also in the film above. Please notice that positions from 0 degrees to 90 degrees are used to machine a bar in main operation. Negative angles, it means positions from -45 to 0 degrees, are used to machine a part in the back spindle. Let's first check position of a bar. It is retracted, and you see it here, and also position in x-axis of this support. It is in upper position, so we can say that this is a safe position for axis travel. In such a situation, we can move in y-axis this whole support to position our centering tool, and at the same time to rotate b-axis to zero position. So we can write and next go down in x-axis to the center of the bar. Now we should determine rotation speed. In configuration of our machine, all tools from B-axis are the driven ones, as you can see in this photo at the bottom. We can start clockwise rotation of the main spindle and also clockwise rotation of our centering tool. They are facing each other, so it means that rotation directions are opposite and there are rotation speeds will add up. Let's write. This is longitudinal position for centering here. But of course, other positions of B-axis are also possible. But in each case, Z-axis should be the tool axis, and the same here. But I'd like to emphasize, and it is very important information, that physical rotation of B-axis doesn't change the part coordinate system. This is the standard part coordinate system. If we rotate B-axis, for example, by angle B, then part coordinate system should be rotated by the same angle. Please imagine drilling an inclined hole in a bar. It would then be convenient to shift the part coordinate system to the position of this hole, as you see in this drawing. Tornos gives us macro G926 to carry up these transformations, I mean rotation and shift of coordinate system, in a very simple way. Here at the bottom you see the syntax of call of this macro. It has a list of parameters, some of which are obligatory and they are presented in black color, and some of which are optional with default value, and they are shown in gray. Of course, it isn't necessary to remember all these parameters or browse through documentation. We have a programming assistant in TISIS. Let's click the wizard icon and then scroll to our macro or just type in its number. Then double-click, and the form with all parameters appears. The first parameter, A, switches on and off the inclined mode. TWP means tilted working plane, so I will use words tilted or inclined as synonyms. Value 1 of parameter A means activation of tilted mode, and it is the default one, so we can leave it as it is. And the next 4 lines is connected with our B-axis position. We will execute centering in the standard longitudinal position, so we will use standard part coordinate system. We don't need any rotation or shift of this part coordinate system. That is why in these subsequent 4 lines we set 0. Next parameter, S, determines if the tool from a B-axis will work in channel 1 or channel 2. Channel 1 is the default one, so we can leave it as it is. The last 2 numbers concern the tool we want to use. So in T parameter, we should enter the number of our centering tool, 302. And the number of geometry of this tool is by default 0, so we can leave it without any change. That's all. We should close this form, and please look, the call of our macro is already inserted. Having the inclined mode already activated, we can position our bar, make a centering with a dwell at the bottom, and at the end retract the bar. So let's write. Next important information is that we have, after each using of macro G926, at the end of this operation, deactivate the inclined mode. It is made by calling this macro once more, but with only one parameter, A equaled 0. And then stop rotation of our tool. And that's all. You can find, of course, the detailed description of macro G926 together with its parameters in Torno's programming manual.